Hi, my name is Christopher Parker. I'm the technical team lead for the NC Simul team here in the United States. And today we'll be taking a look at the Hexagon machine trainer, which runs on the NC Simul software. The machine trainer is essentially a trainer for an inexperienced user, or it can be implemented into colleges and universities to get operators to use their machines correctly ahead of having to do that at the real machine. So instead of on the NC Simul side, where you certify the G code and make sure everything in the programming room is good to go out, now before you have an operator or machinist run it, you make sure that you know how to use that particular type of control as well. So with this machine trainer, we have two different types of controls. This one here is the Siemens control, and then we also have a Heidenhain control on the back side. So depending on what machine you want to train on, which controls you have on your shop floor, you can pick from the exact panel which will mimic the one on the real machine. It's also available in FANUC if you want to put one of those or order that one instead. But this is the one we have here today. So what I want to show you basically is a quick kind of walkthrough of a scenario that you could set up for training. The first thing that comes through, just like on the real shop floor, you can get a setup sheet, and this can be also produced and output from NC Simul. And like you would want to put in all the parameters at the real machine here, we want to make sure everything's good to go. So the first thing we might want to come and do is make sure that our G54, or in this case P3 location on the corner of the part, is set up the same way in the real machine. So using physical inputs, there'd be kind of a panel here on the real one. I can come to my manual mode here first. So I'm going to turn to manual mode and then to my preset management. And then I can check my offset list, so I can see I'm definitely here in P3, and those are my X, Y, Z that should match up exactly with this. Then I can scroll down here to take a look at the tooling list. So I want to make sure that the same thing, all my Z gauges or my tooling length offsets mimic exactly on the real machine. So I can back out, go to my tool table, and see which tools I'm using. So 16 or so, I come down to that one particularly here, and I can make sure that my Z offset is matching any of these. So once I've either input or verified all of these things, I can kind of start to go to the next step. I want to make sure my program's good to go, so I can move from manual mode into automatic mode, and it's going to show me my G code, which is going to be the same one that runs at the real machine. If I need to reset the simulation, I can do so from here, and I'm going to do my stock, and I'm going to start playing the actual code. So the user has access to all the inputs no matter what. We can override the spindle speed or feed rates. We can emergency stop it if need be. If I want to modify the G code, I can do so directly from the panel, and of course start and stop as we go there. So I'm just going to start the machine a little bit, and we'll take a look at it, come in and start to remove an initial first cut, where we're going to verify once again, all of our offsets are good. So it's going to take one initial slim cut around the entire part, and then we can make sure that it's good. We'll see it come to an M1 in the program, where we have an automatic stop just like at the real machine, and then we can go in and take a measurement. So now we've reached our M1 in our program. We've stopped, we had that initial cut, so I can zoom in the software here. So it'd be like kind of leaning into the real machine and taking a measurement to make sure that all our offsets are good on the initial cut. But here I can come in, do a point to plane measurement, take the bottom of that surface, top of that surface, and I'm at my good 1 millimeter called out in that setup sheet. So I'm just going to remove that, back out, or kind of quickly jump to one of my predefined views that I made so I can see my whole machining environment again. And then I want to continue my program and removing the material from here. I'm going to speed it up a little bit on the automatic override so we can get through some more of the machining material. So now you can see what we're running at 120% of the program value, and it's going to start to come in again and remove the rest of the process. At any point, if I see something is going to go wrong, I can just stop the simulation, and I can retract to a safe distance. So I can either do that again in manual mode and just use my Z plus to get back up into the safe zone, or I can actually use one of the jogging wheels on the side of the machine. So I'm going to use the manual, the jog mode here, and then I can choose which axes that I want to jog. So X, Y, Z in the 4th, 5th, or 6th axis directly on this. So we'll do Z, and the speed at which I want to jog it, so we'll go to 100 so we can see something. And then I hold it in, and as I'm moving it up, it moves my machine into a safe zone. And then if I needed to kind of stop, reset the program, put the stock back on the material, make a change in my G-code if I needed to, and then I could continue playing the program all over again. So let's put that into here, put that away, back into auto mode, and off we go. So now that we're a little bit farther into the machining, you can start to see the final piece take shape. If we zoom in here on the material removal, you can see that we're simulating the actual chip flow, the coolants. It's kind of faint here, but you can hear the sound of the machine running in the background. It's showing you the status of what's going on at the top of the machine. If it's alarmed out, you'll show red. If you're powering up the machine, orange. And if it's running well like it is now, it's in green. You can also see all of the same statuses on the NC Simmel window as you could see on the real machine. So you're saying what your type of feed rate is, your XYZ position, your offset that you're used, and you can match them all to the ones that you set at the very beginning. And then as you come to basically getting to your final part here, you can do the same thing. I can pause it at any point. If I want to take an in-process measurement of something that's already been machined, I'll zoom into that point specifically. And then again, I can use my measurement tools to come in here and take a diameter measurement or a radius measurement and make sure that it's going to be up to speed, up to snuff before going to the QC room. So that's kind of the in and out of it. Again, you can use it either in your personal shop for production, have people training on this actual machine while your real ones are being used for production, saving time in both locations, or you can use it in a classroom setting where you can have multiple inputs, multiple controllers in a single unit, therefore kind of reducing your workshop floor space and things of that nature. And it's called the Hexagon Machine Trainer. It's based on the NC Simmel G-code certification software, and it does all the material removal and everything based on physical inputs at this point. Thank you.